So we're going to have a look at this 1992 linear motion question. So it's question 1b, and it says the two particles P and Q are moving in the same direction along parallel straight lines. Their accelerations are 5 meters per second squared and 4 meters per second squared respectively. At a certain instant, P has a velocity of 1 meter per second and Q is 25.5 meters behind, moving with a velocity of 11 meters per second. So sometimes a quick sketch can help at the start of these questions. First of all, in determining which of the particles is behind the other one. And we know that Q is behind P at the start of the question. Q has an acceleration of 4 meters per second squared, and its initial velocity when we start the timer is 11 meters per second. P then is 25.5 meters in front of Q. It has an initial velocity of 1 meters per second, and it has an acceleration of 5 meters per second squared. So what's going to happen in the question? Well, clearly, initially, Q is moving with a greater speed than P. Q is moving with a speed of 11 meters per second. P is moving with a speed of 1 meter per second. And what we'd imagine would happen is that after some time, Q is going to overtake P. Now, because P's acceleration is greater, it has an acceleration of 5 meters per second squared, and Q has an acceleration of 4 meters per second squared, we would imagine that P will get to a greater speed than Q, and eventually it will retake or re-overtake Q and will go ahead again. And then for the rest of the time, P will always be ahead of Q. It has a greater acceleration, it will continue to accelerate, and so its speed will always be greater than Q, and Q won't have an opportunity to overtake it again. So that's the setup of the question. What we're actually being asked is to prove that Q does indeed overtake P, and that P then indeed overtakes Q again. So how are we going to do that? Well, they'll overtake each other if they're in the same place at some point in the future. So how do we figure out what the time is when this overtaking will occur? So if we can figure out that there's 2 times when this overtaking occurs, well then we'll have proved that Q overtakes P and P overtakes Q. So for them to be in the same place in the future, Q will have to travel the same distance as P travels, along with the 25.5 that was between them originally. So he'll have to make up that 25.5 and then match the distance traveled by P. And so we're going to set up an equation for Q in terms of the distance traveled in terms of T, and an equation for the distance traveled by P in terms of the time T. So let's first create a formula for the displacement of P at time T. So we know that its initial speed U is 1, we know that its acceleration is 5, T is equal to T, and then the labeling we'll use for this distance is S of P. So subbing these into S equals UT plus a half AT squared, we have that S is equal to 1 times T plus a half on 5 by T squared. And then tidying this up, we have S of P, the displacement of P, is T plus 2.5 T squared. And so if we sub various times into this formula, we'll find the displacement, or essentially how far P has traveled in that time. We're going to do the same thing for particle Q. So this time particle Q has an initial speed of 11. It has an acceleration of 4. Again, the time is T, and the labeling we'll use for the displacement of Q is S of Q. So subbing them into the same formula, we get S of Q is equal to 11T plus a half on 4T squared. And again, this is a formula that if we subbed in various values of T, we'd find the displacement of Q, or the distance traveled by Q, after a particular time. So again, going back to this equation that we've set up, where we said that overtaking will occur when they're in the same place in the future, and they'll be in the same place when Q has traveled the same as P has traveled, the same distance, but also the extra 25.5, the gap it needs to make up. So we're going to sub S of P and S of Q into this equation. So S of P plus 25.5 needs to be equal to S of Q. So S of P is T plus 2.5 T squared, plus the 25.5, that should be equal to 11T plus 2T squared. So we're going to form a quadratic equation. So I'm going to subtract a 2T squared from both sides and an 11T from both sides to collect all the terms on the left. 2.5T squared minus 2T squared is 0.5T squared. T minus 11T is minus 10T, and then plus 25.5T is equal to 0. We can see that if we multiply across by 2, we get a quadratic of T squared minus 20T plus 51 is equal to 0. This is easily factorizable. We can factorize it by T minus 17 and T minus 3 equals 0. And so our two solutions are that overtaking occurs after 3 seconds initially, that's when Q first overtakes P. That takes 3 seconds. And then P will retake or re-overtake Q after 17 seconds. And so we've proved that Q overtakes P, it takes place after 3 seconds, and that in turn P re-overtakes Q, and that takes 17 seconds. So the second part of the question says that when Q is in front of P, find the greatest distance between the particles. Now remember, Q initially was behind P, and then what happened was that Q overtook P after 3 seconds, and then stayed ahead of P until 17 seconds when P re-overtook Q. So what we're interested in is, when Q was in front of P, what was the greatest distance that occurred? Now obviously, when P overtakes Q again for the second time, P will be ahead forever, and so we could say the greatest distance between the particles will be infinity, because the distance between P and Q will obviously increase forever if P is moving at a greater acceleration than Q is. But what they're interested in is, what's the greatest distance that Q gets ahead of P before P re-overtakes it and goes on and is ahead forever. So when will the greatest distance occur? The greatest distance occurs when the speeds of the two particles is equal to each other. So when the velocity of P is equal to the velocity of Q. If we think about it like this, if the speeds weren't equal to each other, well then that can't be when the greatest gap occurs. If the speed of Q is greater than P, well, Q has overtaken P, its speed is greater, so the gap between the two is increasing, and so that's obviously not when the greatest gap occurs. And if the speed of Q is less than the speed of P, well then P is closing the gap, and obviously then that's not the greatest gap that could occur. So the greatest gap occurs when their two speeds are exactly the same for that split second. So we're going to write formulas in terms of T for P and Q. So P, first of all, again, we know that its initial speed is 1, its acceleration is 5, and the time taken is t. The notation we'll use for the velocity of P is v of P. So v of P is equal to 1 plus 5t. The velocity of Q at a particular time t can be written as 11 plus 4t. Again, its initial speed was 11, its acceleration is 4, and so subbing them into v equals u plus at, we get v of Q is 11 plus 4t. So when will the speeds be exactly the same? So if we let these formulas for velocities equal each other, so 1 plus 5t is equal to 11 plus 4t, we subtract the 4t from both sides and subtract the 1 from both sides, we get that 5t minus 4t is equal to 11 minus 1, t is equal to 10. So the greatest gap occurs after 10 seconds. So remember, Q overtook P after 3 seconds. After 10 seconds in total, that's when the greatest gap occurred, and then remember P narrowed that gap until 17 seconds, and then after that point P was forever greater. So it was at 10 seconds where the greatest gap occurred between the two particles. Now remember that the question wasn't to find the time it took for the greatest distance to occur, but to actually find that greatest distance. So what's the distance between the particles at this time? So I'm just going to start the question, or the displacement. I'm going to have s equals 0 here. So at this point here, this is where Q was originally, and we're going to see how far it travelled in 10 seconds. And then P started 25.5 meters ahead of Q, and we're going to see where it is after 10 seconds. Remember that Q is ahead of P at this time, so we're going to find this gap eventually. So how are we going to do it? So first of all, we're going to sub 10 back into the displacement formula we had for P. So first of all, the displacement of P, we're going to sub 10 into the formula for the displacement of P. That will give us how far it has travelled since the clock started, t equals 0, but then also we're adding in this 25.5 because we're interested in how far away is P from this initial starting point here where Q was originally. So subbing 10 into this formula, we get that S of P is 10 plus 2.5 times 10 squared plus the 25.5, and we see that overall the displacement of P from the original starting point is a distance of 285.5 meters. Now remember, Q is ahead of P after 10 seconds, so we're going to find the displacement of Q by subbing 10 into Q's displacement formula that we found in the previous part. So subbing in 10, we get S of Q is equal to 310 meters. And so Q, from its original starting place, has a displacement or travelled a distance of 310 meters. So what's the greatest gap that occurred? The greatest gap occurred at this point in time, and the difference between the two is the difference between 310 meters and 285.5 meters. And if we subtract those two, we get 24.5 meters. And that was the greatest gap that occurred after Q overtook P, and obviously before P went ahead forever in the rest of the question.